In this section, we're going to be looking for values that are landing on the number line that are below our bell-shaped curve. So with this, the information that will need to be given is the area under the curve, or kind of how we're separating up those areas. One word that's going to come up as a new vocabulary word in this section is the idea of a percentile. A percentile is where we cut off, and it's always describing an area to the left. So that is the value that leaves the given percentage of data below it. So on the right-hand side here, we have a picture, and this is showing the 70th percentile. So the 70th percentile is this number that's landing on the number line. Let's call that X. And that number is landing in a spot such that 70% of the data is below that value, which means we have 30% above that value. So the percentile is always area to the left. So that's one wording that will come up, but there will also be scenarios where they say like the highest 5%. So that would be 5% to the right. Lowest 10% would be 10% to the left. So there'll be different wordings that kind of describe these areas as a percentage, and that's going to be our area under the curve. So let's go ahead and take a look at this. We're going to go and not GeoGebra. We are using Stapplet. And let's go to Stapplet and open up normal distributions as we did before. So we go to probability, normal distributions, and then in operations, there's these two selections. In that last video, we did all of these calculate an area under the normal curve. But now the idea is we're going to know the area under the curve, so we need to switch to calculate a value corresponding to an area. So we're looking for this value. I'm going to set up my mean, standard deviation, and set that up, and we get our picture here. And then we're going to have these options. Calculate boundary values for a left tail, right tail, or central area of, and then we plug in the area in a decimal form. So is it the mean and standard deviation? And then, for example, if we wanted to find the 70th percentile, what I would do is set a left tail, because percentile tells me it's going to the left. And then because it's 70th, I would plug in 0.7 as my area. And there, that's going to separate up the areas, so a lower 70%, upper 30%. And the value on the number line is a 44.1952. So that's our actual cutoff, which in this case represents rainfall. So 44.1952 inches of rain. If it helps, there's this option to show labels on plot. That'll show you how these areas are working. So we see that 70%, we see where that cutoff value, and that can give really nice context of what is going where. So with this, let's go ahead and continue our rainfall example. For these, I'm not going to fill in the number lines because this is a bit harder to guess where things are landing. So I'm just going to put the middle number in there, but I'm not going to label the standard deviations. We'll work a little more free form here. So the first scenario, we're looking for this lowest 10% of rainfall, which would be the same thing as saying the 10th percentile. So what that would do is I would have some cutoff value, maybe over here-ish, and let's call that X. And we're cutting that in such a way that 10% of the data is to the left, which means 90% of the data is going to be to the right-hand side. We only need one of those numbers, but this can be nice to kind of seeing both sides. So in terms of my probability notation, what's happening here is I'm looking for the probability that X is less than or equal to, and then some unknown number. And that probability is 10%. So it's like we're filling in a blank for a different spot in this case. So I just need to find what that X value is. And that's where we go to Stapplet. And this will be a case of left tail. And I just need to adjust my area to 0.1. So now I have 10% to the left, and that cutoff is a 29.7476. So I would say the cutoff for the lowest 10% of rainfall is, and then I'm going to go ahead and round this to 2 decimal places, 29.75 inches, because the units here, the units for my answers for these cases are going to match the units for my mean and standard deviation, because it's all landing on that number line there. So make sure that the answer you're getting out here, it's not a percentage like those previous cases. We're using the percentage to form an area under the curve. The answer we're getting out matches what the numbers along the number line represent. Okay, highest 5%. So out here somewhere, I'm going to have a cutoff. So we have an upper 5%, which means we have 95% below. So that's where this could represent the 95th percentile. Using the wording they're giving, it's like we're looking for the probability that x is more than or equal to, and then some cutoff value that we don't know. And the probability being larger than that is 5%. And we just want to fill in the blank for that missing number. So let's switch this to area to the right, 0.05. And there I can see my 5% and a 53.1588. So the highest 5% of rainfall is above about 53.16 inches. Okay, last one here, middle 50%. So with this one, this is where we're going to switch to finding the central region. So we're going to set central and then 50%. So what that's doing is it's centering 50% of the data around the mean there, and it's giving me a lower bound and an upper bound. So we have a 34.6041 and we have a 45.3959. So we could say the middle 50% of rainfall lands between about 34.6 and 45.4 inches. Okay, so we have these two methods here that we'll be using with our normal distribution. First case is given a cutoff value, finding an area under the curve. And the second one is given an area under the curve, finding a cutoff value.